Thank you, and thank you to the organizers for inviting me to this splendid forum. Father of 3D printing is a little bit of an exaggeration. It sounds as if I originated it. I certainly didn't invent 3D printing. It's been around for 30 years, and I started working on 3D printing early in this century. Now, I'm not going to say an enormous amount about the technology of 3D printing, but I do want to say something about its special capabilities in terms of technology in general and how it might change the way manufacturing gets done in the future. Now, you'll notice that my title is Manufacturing. What I'm talking here about is self-replicating machines, and 3D printing will be an example of this. And what I want to address is something that's already been mentioned in this forum today, and indeed has been mentioned widely in the press over the last few years. It's the idea that AI and robotics is going to lead to considerable changes in the way we work, and possibly to mass redundancies and unemployment as more and more work is done by machines, leaving nothing for human beings to do. Now, when you look at me, you'll be able to see that I'm terribly old, and there are very few advantages to being terribly old, but one of them is that you get to see cycles of things going round and recognize them for what they are, the long periodicities in human affairs and human events. And this particular idea, the idea that technology is going to make everybody redundant, is an idea that I've seen 3 times in my life. The first time was when I was in my late childhood, when mainframe computers were becoming widespread. And there were documentaries on television, I remember seeing them, saying that soon nobody will be working. And there was a newspaper article I read saying that we weren't going to have enough room for all the golf courses that we needed because nobody would be working anymore, and so we'd need so many golf courses for people to spend their leisure time. That didn't happen. The second time that this idea came about was in my early middle age, when the microcomputer started to become widespread. And once again, everybody said, nobody will be working in the future, machines will do everything. And again, it didn't happen. Now, this time, maybe it will. I mean, all we can say is that induction from 2 examples is probably not very statistically sound. But even if it doesn't lead to mass unemployment, it will certainly lead, the introduction of AI and robotics, to radical changes in the way that most human beings are employed, even if they continue to be employed. So, let's look at making things and how human beings go about creating wealth in the traditional way. Now, everything in this room, the clothes you're wearing, the tables you're sitting at, the projector that's projecting my slides onto the screen, were all manufactured by companies. Things are made in the world by companies. So let's start by looking at companies. And let's start by looking at the biggest companies in the world. According to Forbes magazine, the world's biggest company of all is the International Bank of China. And these companies are so big that we have to go to exponential notation in order to describe their size. The International Bank of China has 3.3 times 10 to the $12 in assets, which according to Forbes makes it the world's biggest company. And we go on down the list, and the first thing we discover is that the first 6 companies on the list don't actually make anything at all. The Bank of China and all the others are actually financial institutions of various sorts, and all they do, all these top 6 companies in the world, is they maintain a list of numbers in their computers, and their one function is to ensure that when they subtract a value from one of those numbers, they add exactly the same number to another value, another number somewhere else. That is all these companies do, the top 6 of them, and they're the biggest companies in the world. We have to come right down to number 7, ExxonMobil, at 3.5 times 10 to the $11 in market capitalization, for the first company that does something other than changing numbers around. Now, I realize that market capitalization and assets are not quite the same thing. Of course, different companies have different ways and different measures. ExxonMobil, as I say, number 7 on the list, is the first company that actually produces something physical. We all know what they do. They take dead dinosaurs out of the ground, and they put them into the petrol tanks of our motor cars. And we carry on down the list, and the first engineering company that manufactures items at number 11 is Toyota, 2.4 times 10 to the $11 market capitalization. And then immediately below Toyota is number 12, Apple, sometimes called the biggest company in the world, at 7.4 times 10 to the $11 market capitalization. Apple, it is certainly true to say, does have the biggest market capitalization, but that doesn't necessarily make it the world's biggest company. So these are the tops of the lists, a selection of them. I haven't put all 12 at the top in there, but you get the general picture of what's going on. Let's now look, instead of at the world's biggest companies, at the world's biggest industry. What the world's biggest industry is won't come as a surprise when you think about it. It's this one. The world's biggest industry is food. As I say, that's not surprising. We all eat. And this is not only the world's biggest industry, it's our single most important industry. If this industry weren't there, we'd all be starving, all 7 billion of us. Now, there are some big companies associated with the distribution of food, but the actual production, the farming part of it, those people who do that, and some of them are companies and some of them, of course, are just individuals, they don't grow very large at all. And this is a strange thing. Why should it be that the world's biggest industry does not have one of the world's biggest companies associated with it? What is it about farming that prevents it from accumulating in an enormous size to the size, say, of Toyota or one of those banks that I mentioned? Now, this is only a hypothesis from me. I don't know if this is true, and it's not something, as far as I've been able to tell, that's been researched. But I think that the reason why farming doesn't grow big is because uniquely among all human industries and wealth-creating activities, it is entirely based on self-replication. Everything that a farmer does is to grow plants and animals, and those plants and animals are self-copying. And it seems to me that that is the reason why farming doesn't get big. It's because anyone can do it. There's a continual supply of people coming in at the bottom. It's very easy. Of course, you need land, but quite a few people have access to land. It's very easy to start off in a small way. Almost no capital is required. I can grow plants in my garden, some of which feed me, and the amount of money required for me to start doing that is almost zero. Now, that's not to say that farming everywhere in the world is easy. Of course, sometimes it's quite difficult. But of course, in general and on average, it's based, as I say, on things that copy themselves. And because it's based on things that copy themselves, things that grow, you don't actually have to do any manufacturing yourself. The things manufacture themselves. Large numbers of people can get involved in it, and it tends to stay distributed among those large numbers of people. It doesn't accumulate together in economies of scale, and we'll talk about economies of scale in a little while. Let's look now at manufacturing in another way. Here's a pie chart of global annual manufacturing output. Now, I should warn you to take the figures here with a little bit of, not to trust them absolutely. I worked them out myself. It's almost impossible to find values for this in the peer-reviewed literature. Indeed, I couldn't find any. I could find some numbers on which I based these figures, but they are only my calculation. They're not something that has been itself peer-reviewed. And I've split global manual manufacturing into two rather unequal sections, as you can see here. We've got this large blue area, which I've called P, at 5 times 10 to the 12 metric tons. Now, this is the reason it was difficult to get numbers for this. I wanted numbers in something actual physical, actual mass. It's very easy to find these numbers in terms of dollars, but that doesn't tell you actually how much stuff is being made, how many protons and neutrons are involved, you know, the things that weigh things. Anyway, we've got this enormous great blue area of 5 times 10 to the 12 tons global annual manufacturing, and then there's this tiny little orange sliver that you can just see at 3 o'clock there, which I called EP, and I'll explain what P and EP mean in a minute, and that's almost 1,000 times smaller. What are these two types of manufacturing? Well, they're these. P stands for phenotype. Your phenotype is the color of your eyes, your height, or if you were an oak tree, it's the shape of your leaves, Or if you're a whale, it's the fact that you have fins to swim in the sea. If you're a bacterium, it's that you have a flagellum that allows you to swim through water. Your phenotype is the body that you have if you're a living organism. It's the thing that's built by in the instructions in your genes. And the great global manufacturing activity that happens on this planet is nothing to do with human beings. It's living things growing. It makes an enormous amount of stuff, growing does. The tiny little orange sliver is not things growing. It's something called the extended phenotype of different animals. Animals mainly, one or two plants have extended phenotypes as well. The idea of an extended phenotype was originally created by the biologist Richard Dawkins, who's a very famous biologist, of course. And what it is living things like birds and human beings not growing, but making things from material they find lying around. Let's look at that in a little bit more detail. Extended phenotype manufacturing, here it is. We all know how this works in nature. Birds go out and they gather together sticks and leaves and bits of moss, and they build themselves a nest. And exactly the same thing is done by human beings. We go out and dig in the ground and dig up iron ore, and instead of making nests, we turn it into motor cars, or indeed, we make a nest for ourselves. And here we are all sitting in one of those nests that we've manufactured. This is part of our human extended phenotype. What extended phenotype manufacturing is self-replicating machines. Birds are machines, we're machines, all living things are machines. Self-replicating machines building useful items from stuff they find lying about, ultimately. And as I say, this is a tiny part of all the manufacturing that happens in the world. It's almost nothing compared to plants and animals and microbes growing. So, we can see that self-replication allows vast wealth production, that's the natural world, compared to extended phenotype production. Self-replication is really incredibly effective at making things. And as I say, the reason that farming stays distributed among people is because of this incredible efficiency of self-replication. Farming uniquely is concerned with self-replicating items as part of its manufacturing process. All other engineering, all other manufacture is all extended phenotype production. It's all manufacturing not using self-replication. Well, this prompts an obvious question to us. How can we transfer the power of self-replication from farming into engineering? If self-replication, if the living world, if growing things makes so much manufactured material, how can we use that in engineering in order to make engineering as effective as the natural world? And an obvious question that follows from that question is, if we do that, what will it mean for industry? How will industry change if we start to use self-replication in order to manufacture things? Well, this is where I sort of come in. The idea of a self-replicating machine, an artificial self-replicator, certainly is not mine. It goes way back in history, certainly to a conversation between the philosopher René Descartes and Queen Christina of Sweden. Descartes maintained that living things were machines, and Queen Christina asked him, well, see to that clock that it reproduces itself, or see to that it has babies. She thought she'd found an argument against Descartes. It was a good argument at the time, and it's still not a bad one. She was a very, very, very gifted and intelligent woman. My small contribution to this is the RepRap project. RepRap is short for Replicating Rapid Prototyper. Rapid Prototyper is what some engineers called a 3D printer. And here's a picture of one. This is a RepRap, which is called Lorentz. Most 3D printers that I personally get to name, I call after biologists because they're all self-replicating 3D printers. And that 3D printer you can see in the picture there, all the white parts of it that you can see are parts that it prints for itself. So it doesn't make all of itself. In fact, it makes 65% of itself, this particular one, which is not bad going. You probably think that you grew yourselves and that you're entirely self-made. This is not quite the case. In fact, human beings make 60% of themselves. The reason for this is straightforward. You are made by and from proteins, and proteins are made of amino acids. There are 20 amino acids, And you and I, all of us, can only make 12 of those amino acids, 60%. The other 40% we have to get from our food, that we rely on other living organisms to manufacture that 40% of ourselves. Now, if this was a machine that just printed itself, that might be intellectually interesting, but it wouldn't be much use. But it doesn't just print itself. It's like the products of farming, like wheat and cows, which also copy themselves, but they make useful stuff for us in addition to that. Wheat makes bread, cows make milk, and we eat and drink the bread and the milk. All the self-replicating species that we use in our agriculture don't just copy themselves, they also produce something useful, meat, cotton, whatever it might be, for us to use. And RepRap is just the same. When RepRap 3D printer is not copying itself, then it's producing goods which are useful for people in other ways. Maybe a calculator cover, maybe a comb, maybe a cat flap for your cat to go through in your door, all manner of different objects the machine can make. The name of this particular machine is RepRap Lorenz. Lorenz is the name that I chose for it. It's after Konrad Lorenz, the noted zoologist. All the RepRap machines I get to name are named after biologists, because biology is the study of things that copy themselves. And one final point to make about RepRaps is that they're fully open source. In this case, all the designs for the machine, all the documentation, all the software and so on, is all available under the GPL open source license. And the reason I did that when I started the RepRap project, and I've carried on with it ever since, is because if you have a machine that copies itself, it's kind of crazy to try and patent it. If you patent a machine that copies itself, what you're saying to the world is, here's a machine that copies itself. Now don't copy it. Which is, I mean, I've got better things to do with my time. So I decided to open source it completely so that anybody can make copies of this machine. And indeed, you can find the design for that online if you want. Okay, well, anyone with a plant can grow a seed for a friend, obviously. So if you're growing seeds in your garden, you can grow plants in your garden, rather. You can take the seeds of those plants and give them to your friend, and your friend can then grow the same plants. Anyone with a RepRap can make another RepRap for a friend. And there's a picture of the very first RepRap replication. There's me on the left, as you can see. And that RepRap machine that is there is the very first RepRap machine that we manufactured using a conventional 3D printer. That's the parent machine. And the machine on the right, the parts for it were printed on the machine on the left. And the man on the right is a man called Vic Oliver from New Zealand, and he's another guy on the RepRap project. And that very first replication happened on the 29th of May, 9 years ago, as you can see. When we put the second machine together, the very first replicated machine, sadly it didn't work. But the reason it didn't work was nothing to do with the design of the machine. We'd actually made a mistake. We'd cut one of its drive belts too long, so it was too slack, and we found that if we just held a screwdriver against it to tension the belt, the machine worked perfectly. So we immediately sat down and we designed a belt tensioner for the machine. We printed it out and we fitted it to the machine, and then it worked fine from then on. Now, this illustrates something that you get sort of for free with any self-replicating machine, which is self-repair. If a machine can replicate itself, it can repair itself, or if it's so broken that it can't work at all, then another self-replicating machine can make parts for the first. So it's inherently self-repairing, this technology. I mentioned earlier that I was going to talk about economies of scale, and I'm sure this is an idea with which you're all familiar. On the left is a picture of a traditional blacksmith's workshop, and 500 or 600 years ago, if you wanted a shoe for your horse or if you wanted a hinge for your gate, you went to this man, and it always was a man in those days, and he would make you those things. And there was one of these people in every village, and perhaps several in each town, to service the needs of everybody who needed metal objects manufactured for them. And this was a distributed form of manufacturing. If one of these blacksmiths was ill in your village, you could probably go to the next village and get the blacksmith there to make you a hinge for your gate. All right, you had to ride your horse over there, but that wasn't a big deal. So it was a rather robust way of making things, but it wasn't very economic. And Adam Smith and subsequently other economists have pointed out that if you gather together large numbers of people in one place and dedicate their activities to achieving a particular result, then that's much more economic. And on the right, we've got a picture of a 19th century iron foundry, which is doing the same thing as the blacksmith, but on a vast scale. And the metal items that that iron foundry made were much cheaper as a consequence, because of all the savings that were possible because of economies of scale, than the items produced by the blacksmith. But, and here's the most important point, life doesn't always move in that direction. We don't always take small activities and gather them together to make the same activity work more efficiently with large economies of scale in big factories. Sometimes, when a technology gets cheap enough, and when it gets simple enough, and by simple I don't mean it's internally simple, I mean it's simple to use, cheap and simple technology reverses economies of scale. So, again in the 19th century, on the left-hand side there, we've got a picture of a laundry in London, and our great-grandparents, when their clothes got dirty, used to parcel them up and send them to the laundry in the town, and then 3 days later they'd come back clean. Now, none of us do that anymore because we've all got a robot in our kitchen to wash our clothes. It's there on the right, and when our clothes get dirty, all we do is we throw them in the hole in the front, put a bit of soap in it and press a button, and come back an hour later and hang them out to dry. Very simple process, very convenient, much more convenient and quick than sending it to a centralized laundry. And most interestingly, after washing our clothes, that robot that washes them spends about 90–95% of its time idle. We're perfectly happy to buy that robot and have it do nothing most of the time. And we've taken an economy of scale, the town laundry, and we've taken it back to ourselves. And the same thing is happening, for example, with electricity generation. If you look on the roof outside, you'll find there's an array of solar panels. This building generates some of the electricity that is running these lights in here now. We used to generate electricity in large 2-gigawatt power stations, like the one on the left there, but nowadays many of us generate our own electricity because this has again become convenient and cheap, and it's been distributed. And this gives much more robustness, just as the old single iron worker, the old blacksmith, when he worked, you could go to the next village to get something made when he was sick. Similarly, if the water supply to the town laundry fails, everybody's clothes stay dirty. If your washing machine robot fails, you just go next door, and next door neighbor will wash your clothes for you. Distributed system is much more robust. Distributed electricity generation is also much more robust. Well, this carries over into various other areas. Today, everyone has their own CD pressing plant. You all have one. You all have a photographic lab of your own. You all have a printing press of your own. Of course, they don't look like those traditional versions of these things. They are all incorporated in your computer. But nonetheless, that's something that used to be run at centralized economies of scale manufacturing facility, which you've now taken back to yourselves, distributed amongst ourselves. It's something that's run individually. Well, if we're doing that, why not take manufacturing itself, production, and take that back to the individual level and have everybody run their own factory? And if we're going to have everybody run their own factory, let's make sure that it's a factory that makes more factories, because that will allow us to do, with the whole of manufacturing wealth creation, what agriculture has forced on the economies of agriculture. Agriculture stays distributed among many, many farmers all over the world because I contend, and it is only a hypothesis of mine, remember, I contend it stays distributed because agriculture deals with things that copy themselves. When our manufacturing facilities copy themselves, then wealth creation will be similarly distributed amongst many of us as agriculture is currently. And this will, I hope, have the effect of evening out the spread of wealth rather than causing it to be concentrated in one or two people's hands, because the economies of scale that we saw earlier is the thing that effectively also causes wealth to be accumulated in large amounts in one place. There is only one Facebook, billions of people are subscribed to it, that's an economy of scale, and the wealth all goes to Mark Zuckerberg in that case. So, if we make our manufacturing based on self-replication, the effect of that should be to cause wealth distribution to be more even than it is at the moment, because the people who are creating the wealth will be more widespread, and it will be done at a more individual level. And the simplicity of doing it that way, as these machines become as easy to use as a washing machine is to use, should allow large numbers of people to take part in industrial manufacturing without manufacturing being concentrated in one big Toyota factory or one big Boeing factory. Now, I'm not saying that people are going to be making intercontinental aircraft in their own spare bedroom. That's clearly not going to happen in the near future. But I can certainly envisage a future where a small group of people, perhaps 10, each with their own 3D printing facilities, could print all the parts needed for an electric car for one of them. And that would be a fairly significant change in the way automobile manufacture happens. So, if we have self-replicating machines and we based our manufacture on self-replication, that should lead to a greater, more even distribution of the creation of wealth. That's pretty much all I have to say. Thank you all very much indeed.
It's quite an interesting time that we live in, and drones have really become a topic that no matter where you go, people are talking about it. And so we're going to look at a few different things in regards to drones and how we're using them for social good. So my name is Romeo Durscher. I work at DJI, and that by itself is a very fascinating story. We have a Chinese consumer manufacturing company that's world leading. That has never happened before. So a lot of interesting pieces are coming together in all of this. And over the next 30 minutes or so, I'm going to be taking you through a variety of different scenarios, and I'm a storyteller, so forgive me if I'm going to be telling a story, but I promise you I will make it fascinating and interesting. So this is a picture of your beautiful city, not from a drone, because there are height limits in most countries around the world, but this is from the International Space Station, taken right over Seoul, Korea. And I used to work at NASA, and NASA does one thing really, really well, and that is science, technology, engineering, and math outreach, STEM. STEM in the United States is a big topic, but there is a component missing, a very important component missing. And at DJI now, I have the ability to utilize that missing component, and that is the A for arts. And it's STEAM, because we cannot forget that a lot of people are artistically inclined. They're not scientists, they're not into technology, they have problems with math, but boy, give them some paint and colors and a canvas and they create art. So here's something I have learned. A picture of myself flying a drone ended up on the Associated Press. And if there is a formula, something really interesting happens. And the formula is a crazy drone story and a lazy journalist. If you add those two together, you get something like this. Drone reportedly collides with passenger plane in London, and there's a picture of me flying my drone. Drone knocks woman unconscious at Seattle Pride Parade. And guess what? There's a picture of me flying my drone. Drone war. German court throws out case by family of slain Yemenis. And there is my picture again. If you believe the American media, I have really done it all. Including, I can spy on people. Now this one I really like because it makes me look like a teenager. That's not too bad, right? Man accused of using drone to spy on hospital patients is acquitted. And there is my picture again. But boy, it gets better. I promise you, I did not do this. This is the only one that is photoshopped, because if you have a headline that says, drone follows woman from bar, crashes into her car, you can only have a picture like that. My point is, the way we see and learn from media shapes public opinion. And what we have learned over the last couple of months is something that we want to see more. And that is, drones are here for a positive purpose. And we're going to look at that a little bit more. But before we can dive into this, I have to give you a little bit of background information on not only myself, how I got into this, but the industry by itself. So this is the very first time I took a droney. A droney is a selfie taken by a drone. And that sparked my interest in aerial photography. And so I decided, you know what, let's see where else I can put myself and take a picture with the drone. And if you look very closely, you can see me on top of this rock, and now you get scale. You can see how large this wave is. So aerial photography allows us to see our environment in a completely different way. So then I decided, well, why don't I go and travel with a drone? So I started traveling, and I started visiting some of the most beautiful areas, and I would use my drone to create aerial art, like here in Paris, or then in Riga, Latvia, or Hong Kong, or Cabo San Lucas in a very creative way, or yesterday, your beautiful city. And this is interesting because you have an official drone park in your city. And so I went to visit it, and I took an aerial panorama of it. So as you can see, drones are not only here to showcase what aerial technology can do from an artistic perspective, but you can actually go and meet people. I was on the field, and I met someone at the field that I had been in touch via social media, but we had never met before, and we just happened to be at the same time at the same field. Imagine that. So, now let's look at DJI a little bit, because we need to understand the whole concept of how does DJI fit into all of this. So, DJI is 11 years old. It's a fairly young company, but it is now the leading manufacturer of consumer and commercial drones. And the big change happened around 2013 when the first Phantom drone was released. And the Phantom drone is that white drone that most everyone has already seen a picture of. And from there, things really became interesting, because now we started seeing drones that had integrated cameras, that had stabilization systems to really provide incredible strong footage, but that also made flying very easy. The company itself grew dramatically. 3 years ago, when I joined DJI, there were 1,200 people working there. Today, we're over 11,000. That by itself, that growth by itself is challenging. Even though the headquarters is in Shenzhen, China, it is a global company. And that's a very fascinating part, because we're not only seeing drones being used in the United States or in Europe, but we're really seeing it being deployed all over the world. And what started out as a consumer company, a company that produced hardware from camera stabilization technology to flying drones for the everyday consumer, for the artists, turned out to be something very different today. We created these platforms for the everyday person that wanted to go to the park, that wanted to go skiing and maybe take a very fun video. And so much has changed that we're now seeing drones being used in public safety, in construction, in inspection, in agriculture, in media. We are seeing the change from a consumer product into a commercial enterprise tool. So that brings me to drones for good. And let's look at a few examples of what we've done in very recent history. So for example, after the big earthquake in Nepal, teams went down to Nepal and they helped map areas of destruction, and then not only mapped them, but printed them on large canvases and put them on the ground and brought the village together. Together with the people who live in that village, they looked at the buildings, they looked at the destruction, and they worked together on figuring out which buildings needed to be built or fixed faster than others because they had more importance, because they were either hospitals or banks or any structure of importance. So it became really a community project. The refugee crisis around the Greek coastline, we were seeing hundreds of makeshift boats come across with refugees that had spent days and weeks trying to find a new place, that were tired, and those boats sometimes didn't hold up and they had to swim. And thanks to drones, we were able to spot these refugees in the water much faster, send out boats, pick them up, and save many lives. Texas floodings. This is a very interesting case because actually one of my very good friends, he attached a lifeline to a drone and flew it across to the people that are in that house so that they could rescue them. So we're now seeing drones carrying life-saving equipment, and that's a major change in the way we think about this technology. Now let's move to just the last 3 months. In around the end of August, we had Hurricane Harvey, and Hurricane Harvey in Texas was massive. 20 trillion gallons of rain. That's about what New York City needs for 5 decades. That's a tremendous amount of water. There was a tremendous amount of flooding that Moody's analysts say roughly $100 billion in damage. 185,000 homes were destroyed. And by the end of August, there were still 200,000 people that had no power. So we had drone operational teams, public safety teams, use drones to go and assist during search and rescue operations. They would also go and scan areas of interest, for example, levees and riverbeds, to see if they had any sort of breaches so that they could prevent any further floodings. They would use them to do inspection of facilities that were flooded, like this water plant here that was completely flooded, no access by foot, so they used the drone to go and inspect it, or to go and inspect buildings where actually people were still living in and it was completely unsafe. Then just a few weeks later, Hurricane Irma happened in Florida. And this was another massive hurricane that struck and had high winds, a very large eye of the hurricane, and destroyed along the way Caribbean islands, just massive. In Florida itself, about a quarter of homes were destroyed. 1.7 million people had no power. Majority of utilities were out. So what happened was initially 16 teams, later on 22 UAV teams got deployed right before Irma hit Florida. And as soon as the winds were okay, they started flying utility inspection projects. They were looking for power masts. They were looking for cell phone towers, looking for the damage, reporting that damage back to utility companies so that they could already send out help or repair work much faster with more information than they were able before. And here's a very sad topic close to where I live, the wildfires in California, especially the one over the last 3 to 4 weeks in Santa Rosa, Napa Valley, Sonoma Valley. Very destructive. And I spent actually the last couple of weeks there using drones to assist in a variety of different scenarios, and seeing that destruction that Mother Nature has, in this case fire, and then seeing how drones are being used to not only map areas, but to help with recovery efforts. amazing. Here's a 360-degree panorama I took of one particular community that got completely destroyed. There is nothing standing except a couple of trees. So what we did here is we actually took a 3D map. We flew the drone, we created data, we built a 3D map. And these types of maps are extremely helpful because they show not only the destruction, but now you can start forensics on it. You can start overlaying computer graphics to recreate what happened. And you can also use all that data to help the public understand what actually did happen during an incident. Last year, we did a project on the Adamello Glacier, and that project was, in essence, to really figure out how would drone technology help mountain search and rescue operations. And we went up onto the Adamello Glacier, and we used drones to see mountaineers incorporating this technology into their everyday tasks. And what we learned was very, very interesting. It was not only a beautiful environment to be in it, but watching these professionals trying to figure out how to best utilize this technology was very interesting. We did, again, maps of the glaciers. We provided these maps to the mountaineers. They could look at data that was only an hour old, and they could plan their ways across glaciers. So what we learned is actually very interesting. Drones have really evolved from a flying device to a data collection device. And the drone has become a decision-making tool because it is providing data to the operator or incident command that can help make a better and faster decision. And when it comes to search and rescue operations, the application is not just trying to find an individual, but knowing where the individual is not is also very helpful because you can do resource management. You can send out teams to different areas then without having that information. Another project we did with the UNDP, the United Nations Development Program Office, was on the Maldives. The Maldives, almost 1,200 islands, roughly 360,000 people, and 80% of those islands are only 1 meter above sea level. Now, if you believe it or not, we have climate change issues, and it is impacting us across the world. And on the Maldives, they see an increase in storms, they see more flooding, and they see more erosion. And so with the UNDP together, we wanted to see how could drones help the people on the Maldives. And let's figure out what is it that is lacking. And in their case, it's a lack of preparedness. When you have 1,200 islands that you need to cover, that's a huge challenge already. So here is what we did. There is some sound to it, so if we don't get the sound, then I will narrate it. So we did go to these islands. We visited some of these very far removed islands from Mali, and we tried to learn what is it that these people are dealing with. And some of these islands are very, very small. They have not a lot of land available, so they farm themselves. But every time there is a big storm that comes in, there's chance of flooding, taking out some of their crops or some of their farms. And so they're losing not only income, but they're losing ground of their islands. So it's eroding, it's going away, it's falling into the water almost. So we wanted to take the technology and we wanted to teach the locals how to use it so that they can start mapping their own islands. And by doing that, by mapping your island, several times a year, you can start comparing your models with each other, and you gather data. You can see what changes have happened over the last duration between different models. You can learn about if there is an incident and we need to send the Coast Guard, for example, where is it safe for them to go on land and evacuate? So there's a lot of data that can be of help, but it has to come from within the community. The communities, they have to learn how to utilize the technology. They need to feel ownership. And if we can achieve that, then these individuals, these communities, these islands, they will try and incorporate the technology because they own it. So this was a very, very interesting experience, because you're bringing technology to areas where there is little technology. On some of these islands, there's very little technology, and yet you're bringing this most modern piece of technology that autonomously flies, takes data, and provides everyone with a completely different view. And merging those two can always have challenges. So now, what does the future look like? Well, if you look at this image here, this is what flooding would look like from a drone. And if you were the first responder and you would have to navigate yourself through all of this, this is difficult. The landmarks are gone or flooded. But what if you have now augmented reality overlays that are live? So suddenly you have street names, you have house numbers, you can even outline where the emergency calls come from. Or if it's a fire incident, and you can see what unit numbers, what house numbers are right next to it, the street numbers, that is incredible helpful information to an operator. In fact, augmented reality now can allow you to do training scenarios. Like in this case, this house is actually not on fire. But with augmented reality, we can overlay a building on flames, we can overlay smoke, and now a training exercise becomes just so much more real. If we look at things through a thermal camera, it can get overwhelming. Look at all these colors. We're not used to that. We look at life through our own eyes in a very different spectrum, and suddenly when we see this, it can be overwhelming. If you need to make a decision quickly, this could be too much information. But what if we just stripped out and showed what's important, the hotspot? And suddenly, if you are a fireman or a firewoman, you would immediately know where in the building is that hotspot, and you could approach the rescue operation very differently. What about aerial live streaming of footage? Let's say your incident command is 50 kilometers away, 100 kilometers away, 1,000 kilometers away, and they need to see exactly what you're seeing in the field with little to no delay. That is the future. That is what's happening right now, where drone footage is streamed live to an incident command center. And that brings me to education, because all of this is only possible if there is education. The opportunity ahead is tremendous. Goldman Sachs estimates that within the next 3 years, 4 years, there's a market of $100 billion. And that market is really driven in these sectors. These are tremendous numbers of possibilities that are out there for a technology that is so new. And what does that mean? That means that in the United States alone, 100,000 new jobs are coming out of this industry by 2025. That means that we need to educate our future operators and future users of these drones in different ways, that they understand how to utilize the technology. And it means that we have an opportunity to really use this technology in fun ways in the classroom, because as we've been hearing all day along, our model of education that we've had for almost 200 years just doesn't work as perfectly anymore as it used to. So we can now really expand the way we want to educate and how we can incorporate this technology into academia, so that by the time we have 100,000 new jobs, that our workforce is ready to take on those jobs. And there is another movie. So we did this summer a project in New York City. DJI has landed on the Intrepid Sea, Air and Space Museum. The Intrepid is hosting one of the very first drone exhibits called Drones. Is the Sky the Limit? This DJI-sponsored exhibit really showcases the history of unmanned aerial vehicles and also displays what this technology has already provided in many different areas, such as agriculture, public safety, and arts. We will also be meeting with young students and inner city kids. Together, we will explore the physics of flight. We will talk about drones, how drones operate, what are the important components, and what else is needed to really use these platforms in valuable and beneficial ways.
The Intrepid Sea, Air and Space Museum is an amazing museum where we blend history, the humanities, and STEM. There's a rich history here of innovation. And so we really take that idea and run with it in exhibitions like Drones Is the Sky the Limit. In the education department, we are now starting to use drones in our demonstrations, in our family programming, and also in our camps. This summer we're running our Camp Intrepid, which is incorporating drones into several of the lessons, exploring topics such as programming and aerospace design. The fantastic thing about using drones in the classroom is that kids already know about them. They're interested in them, they've heard of them, maybe they even own them. So the ability to give them something that they can immediately relate to is really fantastic. They want to know so much about them, more than just what can I do with this at home, but what can I do with it in the future.
So like you could have a smaller drone going into a small space and then finding the bigger area and a bigger way to enter in.
You know, this is the way you inspire the next wave of engineers, the next wave of filmmakers, the next wave of photographers. And we want to give students those tools. We want them to understand how to use them. Because when we take that knowledge and apply it, that's when really incredible things can happen.
I learned about drones and how they fly and work. I think I liked the small one because if I had the small one, I would just stuff it in a very small place and it wouldn't be too big to fit in my room.
So as you can see, this technology, as brand new as it is, has a lot of potential. And there are also challenges. There are a lot of challenges. There are challenges, concerns from the public about either privacy or the safety aspects. There are regulatory concerns, and there are even countries that completely forbid the use of drones. So as a society, every single time when new technology has been introduced and has come along, it took us time to really figure out how to best utilize it, how to best frame the legal framework around the technology so that we can utilize that particular technology. And I don't think this is any different. So it's an exciting time. It's a time that does bring change, that does bring something very, very different. And it's also a time to really learn and explore what is possible. Thank you.
My question is negative effects in the development of drone as well as first topic. I think it will occur a lot of accidents of collision with drones in the air and a sudden drop from the air to the earth. As you talked in your presentation, how do you think about those concerns of many people, and how can prevent these accidents in the future?
Those are some valid concerns. The thing about gravity is it always works. You know, if you let something go in midair, it will always come down. So defying gravity by itself is almost like a miracle, if you think about it. So we have done a lot in the last 100+ years to defy gravity. And we've actually not only defined gravity, but we've gone and left gravity behind. We made our ways to space and we landed on the moon. So we've done quite a lot in only 100 years. Now, if you look at the drone industry, the consumer commercial drone industry is very young. And there's already millions of hours of flight time out there, and yet we have not a single recorded death due to a consumer or commercial drone. So that by itself speaks volumes. The technology and the software aspects continue to improve. Sensors are being added to these platforms that not only detect the environment, but start to interact with what's going on around them or other objects. And so the technology itself becomes safer and safer. Studies have been done already on what is the impact if a drone does fall out of the sky and potentially hit someone. And so we have a lot of data that is helpful. Now, the goal, of course, is that we don't fly drones in ways that could harm anyone. We don't want drones to fall out of the sky. We don't want drones to collide with airplanes. So there's a lot happening behind the scenes, from education to the invention of better technologies to ways of managing everything and airspace, to geofencing, so drones cannot fly into certain areas. Looking at all these advancements, this is very safe technology, and the benefit absolutely outweighs that mitigated risk that is there, and that becomes smaller and smaller as our technology and as our understanding grows.
Thank you very much.